Hello friends, welcome to another video of Zeta Axis, and today we are going to discuss the process of petroleum formation as well as shale gas, tight gas and coal bed methane. Today we will see what is the difference between all these four types of gases. Now here in this diagram we can see conventional as well as unconventional sources of oil and gas. So the first is conventional non-associated gas source. Here we can see that there is gas reservoir over here and there is no oil reservoir. That is why it is called non-associated. Gas and oil are not found together over here. Here we see conventional associated gas reservoir because oil reservoir is also there just beneath the gas reservoir. Then we have Coalbed methane layer over here, which is very close to the surface. Then we have tight sand gases over here. And then we have shale gas. So we can see each of these conventional, that is this, and then others are unconventional sources of gas. So today we will see how they are formed and how they are exactly different from each other. So first let's see the process of formation of conventional petroleum and natural gas. And their process starts in the ocean where the marine organisms, small marine organisms like phytoplanktons or other larger organisms, they die over the years and their body is deposited on the ocean floor. Now remember here, there is very less amount of oxygen at the depth of the oceans and therefore anaerobic decomposition occurs, which is very slow. This leads to the formation of kerogen. There is also layers formed over them. So even the pressure and temperature created by those layers lead to the formation of kerogen. Now again, the kerogen which is deposited in this sedimentary rock, it is subjected to heat and pressure of above rocks which are formed over several million years. And under the effect of these pressure and heat of these layers, it is converted into conventional gas or conventional oil. So we can now see that this sedimentary rock has oil denoted by this black color and gas denoted by this yellow color. This is how petroleum is formed in a conventional way. These oil and these gases, they are under natural pressure. So if we bore a hole from the surface, then they can easily rise up. Now we will try to understand the same process through a animation. So here we can see an ocean floor. This is our ocean and these are the layers in the ocean floor. This is the sedimentary layer which forms the ocean floor. Now over several million years we will see that the sediments will fall from the ocean to the oceanic floor and will form a layer. Now these sediments are from the living organisms like phytoplankton or other smaller organisms and they form this organic layer. Here there is mixture of undecomposed body of these organisms as well as sand particles. Now over the years different layers will be formed above this layer which has undecomposed body of marine organisms. Now there will be heat and pressure because of these overlying layers which are formed in several million years. Because of this, this layer will start undergoing some changes. Moreover, sometimes there could be some crustal activities, some tectonic activities occurring over here. And here we can see that there is this folding. This region has underwent folding and therefore we see that anti-syncline is formed over here. And here we have a syncline. Now we can see that the process of formation of layers continues. We have other layers which are formed and we can also see that this layer has now converted and it has now petroleum in it. So because of the heat and pressure generated by these overlying layers, the kerogen which was in this layer finally got converted into oil and gas. Now because this oil and gas, they are having less density, they will start to rise up from this layer as we can see over here. They will rise up in the form of small bubbles. Here we can see the process clearly. They are rising up. But here there is an impermeable layer. And therefore, when they rise up, they collect in the antisyncline from everywhere. We can see that here it is rising up and collecting over here. And here it is rising and collecting in this region. So it will collect in a reservoir and slowly it will form a reservoir like this. We can see that they are rising up and they are collecting here and here to form reservoirs. This is the gas and this is oil. We see that gas is generally above the oil layer. Now how does gas is formed and how does petroleum is formed. So we can see that when the kerosene is at a depth of greater than 2 km and temperature is from 60 to 120 degrees Celsius, then we get oil. But when kerosene is at depth greater than 2 km and temperature is greater than 120 degrees Celsius, then we get natural gas. So this is the window for formation of gas and this is the window for formation of oil. Here we can see that beyond 120 degrees Celsius, most of the organic matter is chemically converted to methane, and that is why we get natural gas. Here we see that this is the impermeable layer, that is, this gas and crude oil cannot pass through them. There is no space in between this layer for them to pass over, so they are accumulating over here. And this is the source rock. So this is the rock where actually the petroleum and gas was formed. That is why it is called source rock. Now remember these terms because we will use them when we discuss about shale gas and tight gas. Now here is an image which describes this process. Here we can see that this is oil window. So it gives the depth, and this is the gas window. So anything which is below, all the sedimentary rocks which are having the undecomposed part of marine organisms, if it is below this layer, then it will form into gas, and if it is above here, it will form oil. Now slowly it will rise up once it's formed and it will be collected in those regions. We can see that it is collected over here, over here, over here, and over here. So anticline, fault trap, stratigraphic trap, and there are salt trap. So any place in the crust of our earth which has a overlying impermeable cap rock, it will form a reservoir. And we can see that gas is lying over the oil. And they are under natural pressure. So if we drill a hole, it will try to rise up. This is another example where we can see that here is a source rock. The oil is formed here, but then it migrates. It encounters an impermeable layer, then it forms a reservoir. Slowly from this reservoir, it again moves up. And here is again an impermeable rock, so it will again form a reservoir over here. So this is how the oil and gas reservoirs are formed, and these are the conventional source of our petroleum and natural gas. Now let's try to understand what is shale gas and how it is different from the conventional source of petroleum and natural gas. So here in this image, you can clearly see that this is shale gas and it is lying at a depth higher than our conventional gases. And we can see that for extracting, we are doing a horizontal drilling. We will discuss about this later, that why it is done in horizontal direction and what is this process. But before, let's try to understand what is shale gas and how it is formed. So shale is actually a fine-grained clastic sedimentary rock formed from mud. Now in this definition, clastic means broken pieces of rock. So it is a very fine-grained sedimentary rock, which means that the pores in the rock will be minimal, or there will be no pores in these rocks. Therefore, they will be impermeable, which means that oil or gas or any other liquid particle will not be able to pass through these rocks. So these are like the impermeable layers beneath which the conventional gas and oil used to collect. And we can see that shale is the most common sedimentary rock in the ocean basin. And it is also the most common source of hydrocarbons. So the basic mechanism of formation of shale gas is that this is the layer which has the undecomposed parts of marine organisms, or this has the kerosene. Now over the time we have seen that this kerosene will be converted into petroleum. But now suppose that this layer in itself is a shale layer, that is, it's a sedimentary layer which is impermeable, that is, the oil and gas cannot pass through this layer. So the kerosene, which was converted to oil and gas, is now trapped within this layer. It cannot rise up like we have seen for the conventional gas and oil. So the gas or oil which is formed in this layer, it will be trapped within the same layer. And that is why in shale gas, the source rock, the impermeable rock, and the reservoir are all in the same layer. And that is why it is called shale gas, because the gas is trapped within a shale rock layer and we have to penetrate and through this layer and extract the gas. That is why it is called shale gas. That is the gas obtained from shale layer. So here is the summary of shale gas. It's an unconventional natural gas because the method which is required to extract it is not similar as it is required by the conventional gas. New technology is required for extracting these gases. That is why it is an unconventional source of natural gas. They are found trapped within shale formations or shale layer. So because they are trapped in these layers, it is called shale gas. Shale gas is primarily composed of methane, where it has 70 to 90% of methane in it, and it also has heavier hydrocarbons like ethane, propane and butane. It has very small amount of carbon dioxide, nitrogen and hydrogen sulfide. A new method called hydraulic fracturing or fracking is used to extract the shale gas. We will discuss hydraulic fracturing in detail in another video where we will analyze what are its positive and what are its negative, but here we will understand it in brief. So here is the process of hydraulic fracturing, where we can see that this is the shale layer which has our gas, and to extract it we will first bore a vertical hole. This is vertical drilling, and when we reach this layer we will drill horizontally. The reason why we are drilling horizontally is to increase the surface area. If we were to drill it vertically, then only this region which is around this vertical bore will be available for gas extraction. But this horizontal drilling, it increases the surface area from which the gas could be extracted. Once this horizontal bore is drilled, then we will create cracks. These cracks were earlier created by using hydraulic pressure. There would be a pipe with small holes around it, and then hydraulic pressure will be applied regularly to create holes in the surrounding rocks. Now they even use electronically controlled blasts which will create these cracks in the shale layer. Once these cracks are created, a fluid which has some coarse particles like sand particles is inserted under pressure. These cracks, they allow the gas in this layer to flow out, and these sand particles which are inserted under pressure, they keep this crack open. They do not allow them to close once again, because the sand particles are coarser. They are having particles which are much bigger than the clay particles of this shale, and that is why this crack remains open, and slowly gas will flow from these rocks to this tube, and then it will flow up and it will be collected here. So this is how shale gas is extracted by hydraulic fracturing. These fractures were earlier created by hydraulic pressure. Now let's see another unconventional source of gas and oil, that is called tight gas or tight oil. So let's try to understand what is a tight gas and tight oil. Here in this our image we can see that these are the tight sands which has gas or oil depending on the conditions. So let's try to understand how they are formed. Here we have seen that this is the source rock, and normally the source rock, the oil and gas is formed over here, and they slowly rise up and get accumulated in those reservoirs over here, where we can see that natural gas lies above crude oil. Generally it could lie alone, but sometimes it is only oil is present and sometimes only natural gas is present, but mostly both of them exist together. Now suppose several million years have passed since this reservoir was formed. So there would be some activity, some cementation, because of the pressure and temperature between this oil and natural gas and the soil layer over here. And because of this cementation and recrystallization, the soil layer will absorb this natural gas and crude oil, and they will be in a combined form or in a tightly coupled form. So now there will be no pressure. If you dig a hole over here, there would be no pressure existing that gas or oil will rise automatically up, but they would be very tightly attached to the soil layer. And these kind of sources of gas and crude oil are called tight gas or tight oil. Here cementation and recrystallization changes the conventional gas reservoir, which changes the permeable rock into an unpermeable rock. So because of this cementation and recrystallization, this layer of rock which was permeable, it gets converted into an impermeable rock. So here is a little bit detailed understanding. So it is generally formed in the same way as conventional natural gas and deposit is formed. So we have seen that in the similar process, the kerogen is deposited, there is source rock, the oil rises up and then gets collected into a reservoir. So it is formed in a similar manner, but here tight gas is formed around 248 million years ago in Paleozoic formation. The tight gas is generally older than the conventional gas. If we see the total oil deposits that exist today, so 70% of them were formed in Mesozoic age, that is from 250 to 66 million years ago, while 20% were in Cenozoic age, that is 65 million years ago, and 10%, only 10% were formed in Paleozoic age, that is having a age of 541 to 252 million years ago. So these have very higher age, and because of this, millions of years, this reservoir, it undergoes cementation with the soil around it, and therefore it forms a impermeable layer, and the gas or oil in this layer is tightly coupled with the layer, and that is why it is not easy to extract it, and therefore again hydraulic fracturing is used for extracting the tight gas. Here we see it is a conventional gas reservoir which is changed by cementation and recrystallization. So a conventional gas reservoir gets converted by this process, and it leads to reduced permeability of the rock and natural gas being trapped within the rock formation. So we saw because of the pressure and temperature of several million years, the layer undergoes cementation and recrystallization, forming a impermeable rock. Most tight gases formations are found on shore. So it is found on layer, not in the ocean. Now let's see another source of unconventional natural gas, that is coalbed methane. Now this coalbed methane is found very close to the surface of Earth. It is found in the coal seam. The coalbed methane or CBM is formed during the process of formation of coal. We know that coal is formed by burial of vegetation and plantation, and these plantation are deposited in a swamp where there is high amount of water and less oxygen. Therefore, the decomposition occurs in an anaerobic condition, giving methane. Now, because of the pressure of the overlying layers, this methane gets attached to the surface of the coal seams. And because generally these layers have water, if we pump out the water, it reduces the pressure level and allows methane to come out. So this is how the methane is extracted from these layers. Here we can see that how it is formed. Coal is formed by decomposing organic material under pressure and temperature, which we have seen. Decomposition produces methane. There is anaerobic decomposition, therefore we will get methane. Due to pressure, methane gets absorbed in coal. Here we can see that these are the coal layers, and we can see these particles, these yellow particles, as methane. So because of very high pressure, when the decomposition was occurring in anaerobic condition, methane which was created got absorbed within the coal, and with the pressure methane stays trapped on the surface of the coal. So it is basically trapped in this coal layer. A process which is very similar to fracking or hydraulic fracturing is used for getting the CBM, although it varies a little. Here the water is removed to reduce the pressure and allowing the gas to come out. With this, we will conclude our video on the distinction between conventional and unconventional sources of natural gas. If you like the video, then do subscribe to the channel and share it with your friends. If you like what we are doing, then you can support us using the Paytm ID. Thanks for watching the video.